To Section 4, Solving Equations with Variables on Both Sides. When we have variables on both sides, we have to use inverse operations to combine them and get them on the same side. The first example says, what is the solution of 5s plus 13 equals 2s plus 20? We start with the original equation. If you notice, I have the variable s on the left side with 5s, and on the right side of the equation with 2s. I have two options to get my variable on the same side. Because these are both positive, 5s and positive 2s, I could subtract 5s from the left side and from the right side. But if I did that, I would have 2s minus 5s, and I would end up with a negative variable. So I'm going to choose to subtract 2s from both sides because 5s minus 2s equals 3s. You can do it either way. It's not going to matter, but sometimes when we deal with negative numbers, it causes mistakes that we wouldn't have if we were dealing with positive numbers. So if you can, you might try to keep your variable positive. But like I said, either way you'll get the exact same answer if you do it correctly. Now I simply have a two-step equation. I have 3s plus 13 equals 22. I'm going to get rid of my adding 13 first by subtracting 13 on both sides, which gives me 3s equals 9. Now I need to divide by 3, and when I do that, I find that s equals 3. Remember, it's important once you solve for your variable to plug it back in and make sure that it makes sense and it makes the equation true. The next example says, what is the solution of 2 parentheses 3x plus 1 equals 4 parentheses x minus 5? If you remember the last lesson that we talked about, this is going to use the distributive property. We need to multiply everything on the inside of the parentheses on the left side of the equation by 2, and everything inside of the parentheses on the right side of the equation by 4. When we do that, we get 6x plus 2 equals 4x minus 20. Now I have variables on both sides. Again, I'm going to try to keep my variable positive, so I'm going to choose to subtract 4x from both sides. You could subtract 6x from both sides if you wanted to, but like we already talked about the negative numbers. 6x minus 4x equals 2x. Keep your plus 2 equals a negative 20. Notice that the subtraction sign is now going to be a negative. Now it's a two-step equation. I need to subtract 2 from both sides. When I do that, I get 2x equals negative 22. Now I need to divide by 2. Whatever I do to one side, I have to do to the other, and I find that x equals negative 11. Plug it back in, make sure that it makes the equation true. It does, so I am good. The next example says, what is the solution of the equation t plus 8 equals negative t plus 6 plus 2t? Notice in this case, I have a negative t plus 6 plus 2t on the same side, so I need to combine my like terms on one side before I can use inverse operations to get them on the same side. When I combine a negative t and a positive 2t, I'm left with t plus 8 equals 6 plus t. It doesn't matter which way we subtract. Notice we have one t on both sides. But if you notice what happens when I subtract a t from both sides is my t's cancel out. On both sides I have t minus t, which cancels out. So I'm just left with 8 equals 6. Well, 8 equals 6 is not a true statement. When I'm left with a statement that is not true, when I'm trying to solve an equation, I say that this equation has no solution, because when you are combining like variables, they cancel out, and 8 does not equal 6. Sometimes you might solve an equation and you might end up with the same thing on both sides. So if you wound up with like 8 equals 8 or 6 equals 6, that is a true statement, and we would say that that equation has an infinite number of solutions, or an infinite, it means that you could plug in any number and it would make the equation true. But in this case, 8 equals 6 is not true, so it's going to have no solution. Today's assignment is on page 114. It's numbers 10 through 34 even.